Hello, welcome back to this video session. In this video, we are going to discuss about vapor absorption refrigeration system, which comes under the model 4 of thermodynamics, applied thermodynamics syllabus. Most of the time, we use ammonia as the working medium for the vapor absorption refrigeration system, since we can also call this system as ammonia absorption refrigeration cycle. This is the schematic diagram of ammonia absorption refrigeration cycle. The parts involved in this type of refrigeration cycle is the following. First one is the evaporator, and it has absorber, pump, generator, analyzer, rectifier or the reflex condenser, and finally we need to have a condenser and expansion valve. The main advantage of this ammonia absorption refrigeration cycle compared to the vapor compressor refrigeration cycle is we do not have the noisy mechanical device such as compressor as well as expansion valve in this system. We have it's a noiseless refrigeration cycle. That is a main advantage of main advantage of ammonia absorption refrigeration cycle. And let us see the working principle of ammonia absorption refrigeration cycle in an animation video. Just watch this video, we come to know that the working of the ammonia absorption refrigeration cycle.
The vapor absorption refrigeration system is almost similar to a vapor compression refrigeration system, but here we have replaced the compressor with an absorber, hence the name vapor absorption refrigeration is given to this system. In the vapor absorption refrigeration system we are discussing today, we will use ammonia water solution which will run throughout the system. So, we have ammonia, which is the refrigerant that gives the cooling effect or refrigeration effect. And there will be water, which acts as an absorbent. Water has a strong affinity towards ammonia, so the ammonia water solution is formed, and we will use this solution to run the vapor absorption refrigeration process. Now, let's look into the major parts and components, and basic working procedure of vapor absorption refrigeration system. First of all, here we have an evaporator where the refrigeration effect or the cooling effect takes place. There is an absorber which contains the solution of ammonia and water. A pump is placed beside the absorber which is used to pump this ammonia water solution from the absorber to the generator. There is a generator with an analyzer fitted on the top of it, a pressure reducing valve, a condenser which converts the incoming vapor refrigerant into liquid by changing its phase, and finally over here, there is an expansion valve which expands the liquid refrigerant ammonia, decreases the pressure, and turns it into a cold chill low temperature low pressure liquid which will go to the evaporator. So, these major components together construct the vapor absorption refrigeration system. All these components are connected together with these connecting pipes. Now, let's start with the detailed function of the evaporator. Very cold, chilled, low temperature liquid ammonia coming out of the expansion valve enters into these evaporator coils through this connected pipe. We all know that the main cooling effect or refrigeration effect always occurs in the evaporator. So, when this low pressure, very cold, chilled, low temperature liquid ammonia will enter the evaporator coils, it will absorb all the heat present in the surface of the evaporator coils. By absorbing all the heat from the surrounding region of the evaporator coils, this cold chilled liquid ammonia will turn into low pressure ammonia vapor inside these coils, and the surrounding surface of the evaporator will become cold by losing the heat to this liquid. Thus the cooling effect or refrigeration effect has occurred in the evaporator. After that, this low pressure ammonia vapor will leave the evaporator, and enter the absorber through this connecting pipe. The absorber already has a weak solution of ammonia and water inside it, and when this low pressure ammonia vapor enters the absorber, the water present in the weak solution of this absorber will start absorbing this ammonia vapor and the weak solution will gradually convert into a strong ammonia water solution. The more ammonia vapor coming from the evaporator is absorbed by water from this weak solution, the stronger this solution will become. But when water absorbs ammonia vapor it also liberates heat. That is when water will absorb the incoming ammonia vapor it will produce heat which will increase the temperature of the solution. And when the solution becomes hot, gradually the capacity of water to absorb ammonia decreases. So, to keep the temperature of this solution to an optimal level, a supply of cool water is provided through this pipe so that this external supply of cool water through this pipe carries away heat from the solution, and thus water regains the capacity to continuously absorb incoming ammonia vapor. Beside this absorber, there is a pump. Now, when power is provided, then this pump starts working. Then using this pump, this strong solution of ammonia and water will be pumped from this absorber to this generator. So, the function of this pump is to transfer the solution from the absorber to the generator. We provide auxiliary heat or external heat to this generator either by using steam, or hot water, or any heater, gas burner, etc. So, when the solution of ammonia and water reaches the generator, and heat is applied to this solution from the external source, both ammonia and water from this ammonia-water solution turns into vapor inside this generator. Actually, ammonia turns into vapor faster than water, and water takes comparatively more time to completely turn into vapor, but eventually both ammonia and water will turn into vapor when heat is provided. Now, here we also have an analyzer on the top of this generator. When this vapor of ammonia and water tries to pass through this analyzer, only ammonia is allowed to pass through. The analyzer continuously condenses the water vapor and sends water back to the generator. This is because, if water vapor enters the system, it can decrease the efficiency of the refrigeration system, or if larger quantity of water vapor enters the system, then the system could be damaged. Thus, the analyzer separates water particles from ammonia vapor, and only lets ammonia to pass through to the next components through this pipe for further process, and the analyzer sends water particles back to the generator. Then from this generator, the residue weak solution of water and ammonia accumulated here will be passed back to the absorber, again passing through this pressure reducing valve. So, here the high pressure, high temperature pure ammonia vapor coming out of the generator will now enter into this condenser through this connected pipe. Here, we have a condenser. When high temperature, high pressure ammonia vapor enters this cold condenser, then the condenser absorbs the heat from the ammonia vapor, and completely converts it into liquid. This condenser can be either water-cooled, or air-cooled, or cooled by any other substance from an external source, which will liberate the latent heat of this vapor coming into the condenser, and thus condensing keeps happening. Now, here we have an expansion valve. After condensation, liquid ammonia will leave the condenser and pass through this expansion valve. Now, this high-pressure liquid ammonia, coming from the condenser, will be expanded inside this expansion valve. We know that when expansion occurs, the pressure between the molecules decreases considerably, thus the temperature falls. So, this high-pressure liquid ammonia will be expanded into low-pressure, low-temperature liquid ammonia. Thus, here we get very cold, chilled, low-temperature liquid ammonia coming out of the expansion valve. Then, this liquid ammonia will be again passed over to the evaporator through this connected pipe, whereby absorbing all the heat from the surrounding region of the evaporator coils. This cold chilled liquid ammonia will again turn into low-pressure ammonia vapor inside these coils, and the surrounding region of the evaporator will become cold by losing the heat to this liquid. Then this low-pressure ammonia vapor will leave the evaporator, and enter the absorber through this connecting pipe, and the whole cycle will be repeated over and over again. Thus refrigeration or cooling will occur continuously in the evaporator region. So, this is how a vapor absorption refrigeration system works.
I hope this video might have given clarity about how the vapor absorption refrigeration cycle works. That's it, guys. With this, we will close this topic and we meet in the next video. Till then, bye bye and be safe.